All right, so this is an exponential decay function. And I know that because look at the base of the exponential function, so that I know it's exponential because the exponent is where x is, okay? But I'm mostly looking at the 1/3 here. Because 1/3, if the base is a number less than 1, because 1/3 is 0.33, that means the graph is decaying, meaning it starts really big, and as time goes from left to right, or as x goes from left to right, meaning as x gets positive, it's actually going to get smaller and smaller. Okay? So we're just going to make a simple t-chart here. Let's start at -3, and you know what, we'll go all the way to +3. And really there's kind of logic behind this. So notice how it says x plus 2, okay? So really the best thing to do when you plug in these values, because that means actually the graph is going to shift on me, and you'll notice that here in a second. And so we'll talk more in class about this idea of like, well, what numbers do you put in there? Because I know a lot of you have been wondering, well, wait, how do you know what numbers to plug in for x? I mean, really, every graph, the important, exciting stuff happens near where x equals 0, so picking points smaller than 0 and bigger than 0. Okay, but when shifts start becoming involved, then you want to start focusing on, okay, well, perhaps I can pick numbers that would be better suited, because we don't want to pick numbers and then like, oh, nothing happened. So we'll just do -3 to +3, and then we'll talk about that at the end there. Okay, so let's plug in -3. So that would give me 1/3 to the -3 plus 2, and then plus 2. So if I simplify the exponent, -3 plus 2, it actually becomes 1/3 to the -1 plus 2. Which, again, if we distribute the exponent, okay, that's going to give me 1 to the -1 over 3 to the -1, which this moves to the top because we got to get rid of negative exponents. And so that will actually leave me with 3 over 1 to the +1 powers, which is just 3. And then 3 plus 2 gives me 5. So that when I plug in -3, it's going to be 5. -3, 5 is right here. Okay? All right, let's plug in -2. Different color. -2 plus 2 plus 2. So if I simplify the exponent first, -2 plus 2 is actually 1/3 to the 0th power, okay? Which anything to the 0th power equals 1, so 1 plus 2 equals 3. So it's going to give me 3, so -2, 3. Okay. All right, let's plug in -1. So 1/3. -1 plus 2 plus 2. -1 plus 2 gives me 1. And 1/3 to the first power is still 1/3. So 1/3 plus 2 is 2 and 1/3. So 2 and 1/3. Or, again, if I'm doing improper fractions, it would be 7 over 3. Or as a decimal, I believe that would be 2.33. Okay, so -1, 2.33 would be about there. And you'll notice that when we start getting to, when we have fraction answers with exponentials, that's where it starts to get a little bit more interesting, right? Because notice how it's going to get really close to that +2 out in the back there. All right, here we go. So if we plug in 1/3, and we're going to plug in 0 plus 2 plus 2, that's going to give me 1/3 squared plus 2. And then the exponent applies to both numbers, so it would be 1 squared over 3 squared, which is 1 over 9 plus 2, which is 2 and 1/9. 2 and 1/9. And I'll just go ahead and make it a decimal right now, so it would be 2. Actually, I don't know what 1/9 is off the top of my head. Let me plug that in. 1 divided by 9. 0.11111. Okay, so let's see, 2.11. Okay, so you'll notice that, gosh, well maybe we should have picked better numbers, because I only got two values, -3, -2, that gave me whole numbers. And I bet you if we keep progressing with 1, 2, and 3, we're just going to get smaller and smaller and smaller and smaller numbers there. So just for the sake of it, I'm going to get rid of 1, 2, and 3. And rather than that, I'm just going to plug in -4. Okay? And we'll just go ahead and do that. So 5 numbers are fine. I wrote all those numbers to show you to see, like, if we kept going with 1, 2, and 3, we're just going to keep getting decimal and decimal, decimal. But we want to see what it was doing on the other end, because maybe it would be a bigger number. Because it's going to keep repeating this pattern. That's one of the characteristics of an exponential function. So if we plug in -4, new color, what color haven't we used yet? Black, okay. So 1/3 to the -4 plus 2 plus 2. Okay, so if -4 plus 2 is 1/3 to the -2. And remember, the exponent applies to both. So I'd have 1 to the -2, 3 to the -2. These need to switch places. So I'd have 3 squared over 1 squared, which is 9. And then 9 plus 2 equals 11. Okay, so -4, it's 11. So that goes about here. All right, so that is how exponential functions work when there's a shift involved. So you notice the asymptote, or that line that it can't cross, will be 2. And it's always actually going to be this, whatever's on the tail end there, the vertical shift. That's what we call vertical shift when we're dealing with functions. And you'll notice that with many different forms of functions, that when there's a constant value being added or subtracted to it, that's actually going to be, it moves the whole graph where it would be up 2 units. So that's where my asymptote is. All right, so that kind of explains the shift. And notice how the +2 with x, so x plus 2, actually moved the graph over to the left 2. We'll get more on the shifts in another unit, but that's how you would sketch a graph of this function.